All right, over to you, Mike.
Thanks a lot. All right, cool. So let me share out my screen. We're going to be talking about Azure architecture best practices today. And I trust that you guys will holler at me if there's any audio issues or screen sharing issues. All right, so this is a big topic, right? We could go on about architecture best practices for a long time. Normally, I do workshops 3 to 5 days on this topic. Every time people kind of walk out a little bit tired, right? So big takeaway is I can't cover every single best practice, but what my goal is in this talk is to do a couple of things. Number one, share my own real world perspective on things that I've seen over the last couple of years, and also give you guys plenty of resources to go off to ramp up. Big fan of user groups. I actually started doing user group stuff about 10 years ago. I've been in IT just over 20 years. I think I started in 98 or 99. And, but yeah, about 10 years ago, I started doing user group stuff. Really appreciate what you guys do with the group. I think it's a great way to engage, a great way to learn. Community is just, you can't say enough good things about it, especially in the Microsoft space. So with that, I'm happy to be here. Again, name's Mike Pfeiffer, Microsoft Azure MVP. And yeah, let's just jump into it. So the three main things I'm going to talk about today, and I will provide the deck in PDF format because there is a handful of links. But these are the big things that I'm going to talk about. And by the way, this is going to be a theoretical, conceptual talk. Like I don't have time to go deploy a full-blown infrastructure and kind of take you guys through that. So I'll try to keep it as entertaining as I possibly can. And we'll be bringing things up on the screen. But when you get to the end of this talk today, all the resources I'm going to talk about are going to come from these three places. So number one, Azure Architecture Center. Number two, the Microsoft Azure Well-Architected Framework. And then number three, Microsoft Cloud Adoption Framework for Azure. What I've found in the field working with people is that these are massively underestimated resources. But when you're starting out, or even when you're trying to refactor and kind of go back and clean stuff up, these are amazing resources. And, obviously, different companies have different relationships with Microsoft, and the resources you can tap through Microsoft would be different depending on your relationship. So depending on where you work, right, you might have more access to Microsoft through these vehicles, and depending on where you work, you might not, right? So basically, you're going to want to become very familiar with these because, like I said, one of the most underestimated resources. So big fan of Cloud Adoption Framework at the bottom. I'll be talking about that a little bit when we get to the end, quite a bit at the end there. Well-architected framework is something I was excited to see Microsoft bring into their documentation, because when I worked at AWS, that was a big thing that we focused on at AWS. So back in between 2013 and 2016, I worked at AWS as a solutions architect over there. We had the concept of the well-architected framework, just like Microsoft does. And it was just a huge success. So it keeps kind of like, the guardrails on, if you will, kind of keeps you focused, thinking about the right stuff. So what I'm going to do today is I'm going to share the pillars from the well-architected framework, some things to think about in terms of architecting for best practices. I'm also going to weave in some stuff from the Architecture Center to give you kind of a mental picture of how that stuff comes together. Again, it's a massive amount of stuff, right? So I'm going to try to focus on low-hanging fruit. And then at the end, I'm going to show you some stuff from the Cloud Adoption Framework that's awesome for whether you're starting from scratch or going back and trying to fix stuff. I don't know about you guys, but I've worked with several people, several businesses over the last couple of years where you get in there and realize they had good intentions, but there's a bunch of stuff set up that's not set up the right way, right? And it's really hard sometimes to go back and fix that. But I believe that the resources here and the stuff we'll talk about today will help either way, if it's greenfield or you're trying to go back and fix some stuff. So let's talk about these well-architected framework pillars. I'll start with the reliability. If you look in the documentation, cost optimization is actually the first one, but when we're talking about architecture, usually people immediately start thinking about high availability, right? Which is one of the components. And I brought up this reference architecture from the Architecture Center, linked down at the bottom. This is an infrastructure as a service. highly available application. So running everything pretty much on VMs, right? And this is a pretty robust architecture. This might be an architecture you would see for something like a SharePoint farm. And, just kind of looking at it from a high level here, you can see that this does take into account availability zones, right? So we got zone 1, zone 2, and zone 3. We've got our workloads spread across these availability zones. These are all in the same virtual network. This could be distributed across resource groups or a single resource group. I'll talk a little bit about resource placement when we get towards the end. But, one of the things that's incredibly hard is managing an environment like this. One of the things of best practice that we'll talk about is you're doing things in a way that allows you the most flexibility. And so I'm not trying to say like virtual machines aren't flexible, but I think we all know when we're talking about going completely cloud native, virtual machines are hard to go fast. However, we do have workloads that need to be moved from on-premises in many cases into the cloud. And, there's going to be a lot of cases where we do have to do things completely on VMs, right? So this one reference architecture is a good place to start. I'm going to talk about IaaS versus PaaS and stuff like that. But just look at some of the components in here, right? Like on the far left, you've got an application gateway that is, accepting inbound connections from the outside world and distributing those connections across virtual machines. You've got, so that takes care of your web tier. You've got a business and a database tier that are also load balanced with a different load balancer, right? So it's not an application gateway, it's an Azure load balancer. And so when you start thinking about architecture, obviously for reliability, we're concerned with eliminating single points of failure. We want to make sure that, if availability zone 1 dies, a web server and a business tier machine and a database server, potentially in the third availability zone is going to help us out, right? So as an architect, what I tell people is your number one job, or at least one of your primary jobs, is to constantly think about what's the single point of failure and how would I break this thing, or how could I break this thing? So for example, look at the NSGs on every subnet. See how application gateway subnet, management subnet, web tier subnet, all those have NSGs on there. So those are network security groups. Those can be bound to a subnet, and then that controls all the traffic flowing in and out of the subnet. Now, when it comes to NSGs, you can connect it to the NIC or the subnet, but in this architecture, what they're showing us here is using the groups that control traffic that flows from one group to another or one subnet to another. And if I'm thinking like, how could I break this? Well, number one thing is I go screw up the security group implementation, right? And if you look kind of further down the right to the data tier subnet, doing SQL Server on virtual machines, totally doable. That's a lot of work, right? And so they've got a 2-node cluster there. So if I'm putting my architect hat on and I'm looking at that, I'm like, well, there's no SQL Server in zone 2. So that could break things, right? And so it's kind of like constantly understanding the services that we're working with, the patterns, and in Azure, they're available to us that are constantly evolving, and then making sure that we can build something that is resilient to failure, but also, optimized for cost and all these other things we're going to talk about. So this would be kind of just one place to start. The other thing I would say is most people that I've worked with, have a hard time with the networking component. So you see the application gateway versus the Azure load balancer. If I was going for architect certification or just planning on doing Azure architecture work in the field, I would want to have a real clear picture of what's the difference between those, right? Basically, at the end of the day, application gateway is a layer 7 load balancer. It's application aware. So it can do things like path-based routing and routing to multiple backend groups of servers and all kinds of sophisticated stuff, SSL termination, cookie-based affinity, all kinds of things that you would expect to get out of a fancy load balancer, right? An application-aware layer 7 load balancer versus Azure load balancer that we're seeing on the inside. That's just layer 4, right? So that's another architectural consideration is, do we have a stateful application when users come from the outside world and hit the application gateway and they hit VM1 first through that? Do they need to stick with the VM1? Those are the kind of questions as an architect we start to ask ourselves. The other thing that this diagram shows, doesn't show, right, is the concept of availability sets. That's another, kind of confusing concept because some regions in Azure have availability zone support where others don't. So from a best practice standpoint, you're going to get the most availability control in a region that has multiple availability zones. Okay, so first, let me click on the link here to show you the architecture center, right? And by the way, if you just go to the main link that I had on the first slide, it kind of just takes you into this section here. There's tons and tons of stuff in here. But check this out. On the right-hand side, right, there's just kind of the architecture, which is the diagram, recommendations for scalability, availability, cost considerations, security, DevOps considerations, like how we're going to automate this. There's a Visio file, and deploy the solution as well. So even some, infrastructure templates and whatnot. So, when I first started doing, when I left Amazon, left AWS and started doing Azure again, it was right around the era where the Azure Resource Manager deployment model was coming out. So the ARM, system, there was a big transition in that time period from Azure Classic to Azure ARM. But as soon as this architecture center popped up, and I don't remember when that was, maybe 2017, 2018, a little bit after I started doing Azure again, I was in here reading every single one of these. So my advice to you is, if you want to be someone known as a solid Azure solution architect, I'm not going to sit here and tell you to read every architecture, but this is a great place to study, because it will reveal many of the things the folks in the field already know. Like, a lot of the stuff that I mentioned was already on, that I already mentioned is in this, but there's way more that goes into that. So I would become a student of these reference architectures. Okay. So there's a couple of things, just shooting from the hip, that I'll start with. Now, this is a classic implementation just on VMs, right? So we're not really thinking about containers or orchestration or using event-based automation and serverless functions or any of that kind of stuff, or even stuff like Azure App Service. And we'll get into that a little bit. But yeah, this can be kind of a big hill to climb. All right. But a good exercise would be, maybe going in and using some of the templates that are available from Microsoft, maybe if not this one, something out of the Azure Quick Start repository, to spin up a multi-node implementation, maybe with a load balancer. And if you were to go and build something from scratch like that, and you're studying these reference architectures, you'll learn an amazing amount. Okay. That's kind of how I got started, really digging into this stuff. So we'll come back to some of these concepts, but let me move forward here. So, kind of recap real quick. In terms of reliability in this well-architected framework, we're looking to eliminate single points of failure. We want to build architectures that can recover on their own from failure as well. And another big thing from a best practice standpoint is you'd want to understand this concept of composite SLAs. This is, if you're doing certification or just real life stuff, super important. Let me give you an example, right? Virtual machines, depending on the configuration, is going to give you a certain service level guarantee, right? You might be using Azure SQL in a certain configuration, right? So those two different services could have different SLAs. And if you're trying to construct an architecture, that does 5 nines, well, it's completely predicated on the underlying components, right? And there's a great topic in the Microsoft documentation that talks about that concept. I'm not going to drive into the documentation on that one, but you want to be thinking about, okay, what are the different services I'm using? And based on their configuration, what kind of service level guarantee am I going to get? And this is, obviously important in the sense that you might have internal SLAs. Like, I've had customers where, they're building internal systems, and between teams, they have service level agreements, or, more common usually from my point of view and who I've worked with is a lot of times they might have a customer SLA, right? Either way, when you're architecting systems, you got to think about, if you're going to guarantee service level availability, it's predicated on the underlying components. Okay. So those are a couple of things to think about. Let me take you into this link right here. This takes you into architecture, Microsoft Cloud Adoption Framework, or the well-architected framework, excuse me. This takes us into the reliability tier, right? Pillar. And like I said, there's basically going to be 5. We're talking about reliability right now. We'll cover the other ones, but I've added a link into every one. That'll basically take you into a kind of a checklist, right? Again, we have a ton of stuff to possibly talk about in this ecosystem of best practices for architecture. So when you get in here, right, they're like kind of tee up the concept, right? And then down here, all right, some tactical stuff. Define your requirements. Now kind of get into the stuff I was just talking about of, picking, understanding what services you're working with and the limitations, all that kind of stuff, the SLAs. And then they kind of walk you through the process. So like, what should I be thinking about? Well, once I've defined my requirements and I'm starting to architect my solution based on, stuff out of the architecture center and whatnot, in a resiliency scenario or reliability scenario, right? Test simulations with forced failovers. In the cloud world, you hear about this, people really progressive doing this kind of stuff. They call it chaos engineering, right? You ever heard about Netflix and all the crazy engineering they do for their cloud stuff, right? So they actually built an open source project years ago. I think it was called like the Simian Army or something like that. They would just go and like blow stuff up on them. So they were all running all their stuff on AWS, right? But, doing that level of work is what exposes the weaknesses. So yeah, that takes a lot of time to maybe in an independent subscription build out this very production-like architecture that you're proposing. But doing the work of actually going in there, setting it up, and then simulating like what is the crash experience, what's the failover experience, really validating the architecture. I've seen way too many just people building stuff and like, thinking everything will be fine without actually testing, right? So this is an ongoing process as well, simulating faults, stuff like that. And then, one of the things I'll talk about today that they start talking about in here is like application consistency, deployment stuff, monitoring, things like that. So anyways, I've tried to organize these slides so you can dive deeper into each of these, right? And it's almost kind of like a little bit of a cheat sheet, if you will. All right, so this is a huge document. I'm not going to read the whole thing to you, but notice down here, when you get down to architectural best practices for reliability, it's a step-by-step thing, right? So there might be a handful of things in here that you never even thought about. So I would encourage you to dive into that. Moving forward into the next pillar, operational excellence. This really gets into, more like DevOps type of conversations, right? So design, build, and orchestrate with modern practices. And, I think really one of the big things they're getting at here is starting to embrace automation. Are you actually doing your infrastructure as code and having infrastructure changes done in code, run through a series of tests and maybe get deployed to some kind of staging or test environment first before you approve those? That's pretty aggressive in terms of, kind of bleeding edge. But I actually worked with a customer this year that's doing that. Excuse me. And that's actually really fascinating to me because, seeing what people were doing with software before now doing it with infrastructure, interesting model, right? And it allows them to go much faster. So initially you might think, man, that's really going to slow us down, like getting all this stuff in code and putting it in repositories and having all these checks and balances. But, that's long-term thinking versus short-term, right? So I've had several conversations with two of my biggest customers. It's easy to go for the quick win. Like, let's just cheat and we'll just do it manually and set it up and then we'll worry about it later. That always comes back to bite you, in my experience. So if you can take time on the front end to do things right, I had a great customer, or actually there was just one project that I worked with them on earlier this year, but I was amazed by the maturity of their deployment processes. Like literally, if somebody needed to open a port on the NSG, it was done through a code change via pull request into a Git repository, right? And so they literally had it down to that level. That's, like I said, pretty aggressive. It's probably going to take a lot of companies a long time to get to that point. But bottom line is, the more automation, the more, or I guess I should say, the more automation, the less error from the human error element popping up there, right? Coming into play. And then on top of that, another big thing in that world is continuous monitoring, right? That's another thing where that's incredibly hard to do, especially in cloud, especially when people are new at this, right? So, I think Azure Monitor itself, and it's come such a long way. It's still evolving. It's amazingly capable, but it's an area where people are a little weak from my experience, myself included. I mean, there's so many things I could learn about Azure, right, in a given month of time, but it's another spot where I think people need to spend more time, right? And because that'll help you understand what's the performance, which ultimately a lot of times ends up being, oh, we're saving money because we realize we're not using all the CPU and memory on those VMs. We'll talk about that a little bit more in cost optimization. And then also in this world, kind of mentioned testing a little bit in the last one, in the last pillar, but when you're doing automation, testing is key, right? Testing for functionality, testing for security. When you hear the DevOps conversations, people talking about shifting left, like doing your security early, those kinds of things, validation, that's all hard stuff to do. And I don't think that, in every scenario, we really have established practices for testing. And so it's still very, very much the early days, unless you're just doing strict software testing, right? Or load testing, penetration testing, that kind of stuff. When I'm thinking testing, I'm really thinking about end-to-end, infrastructure testing, infrastructure as code testing, down to unit testing perspective, right? Most people aren't there yet. However, that's what we should strive for: automation, and basically, having a clear set of, here's what happened, here's who it was, here's what time it happened, and we know exactly what it was before, what it is now. We can go back if we need to. Now, this thing here, this checklist is awesome. So under operational excellence, if you're trying to make sure that, if you're interested in, hey, what can we do operationally to really raise the bar? Huge checklist of stuff here, right? And even though this is a 2018 article, all these things are still valid, right? Because it's pretty much universal across whatever platform. Some of them are high level, right? Ensure business alignment across teams, stuff like that. But once you start coming down the list, there's some really thought-provoking things I would encourage you to kind of run through here. Reducing cycle time. That's a software concept, right? So some of this stuff might be a little bit foreign, but this checklist goes through not only the culture, which is this whole section here, but the development process. Provide developers with production-like environments. These are just like little gems throughout the documentation. I've been ranting about this one forever, just because every time that's actually been something that has been a problem for me going in with customers, where like the developers don't even have a developer subscription and they have no idea what they're deploying to. And when you're trying to sit there with a team of devs and they don't have access to Azure, it's kind of hard to add value, right? So, if you work in an organization as a leader, I would highly encourage you to look at the different subscription options. This will be here in the documentation as well. And depending on your relationship with Microsoft, you may have a ton of credits, or you may, have MSDN subscriptions for your devs, or you may be able to get dev test subscriptions. But give people access to a sandbox environment. And what I mean by that is a subscription that isn't production, not used for production. There's more guidance for like subscription design and stuff like that. And at the end, I'll talk about a little bit. But that's just one component that I'm hitting here that I've seen like major friction point. So that'd be a best practice, not really an architecture practice, but one that I would recommend. They go into testing, some stuff to think about there. And all this stuff can be applied to infrastructure. So it might seem like it's just software, but really, it's universal at this point for the most part, because just about anything that we can build is virtual at this point, right? Except for the conversations where we're going hybrid and whatnot. Stuff in here about release automation, right? And on and on. So tons of good stuff in here, like small incremental changes, that's just a basic concept, but really, there's a lot of gold in here. So I would encourage you to run through this. Don't have time to cover every single bullet point, but ton of awesome stuff in there. Oh, and one other thing that just to touch on real quick, your deployment patterns, right? Those are good to know about in an architectural scenario, not only for certification, but for real world. So in here where they're talking canary releases, blue-green deployments, you may be able to do that in multiple services, right? So again, from a best practice perspective, it's like figuring out what it is you're going to be using first, right? Coming up with a concept. And then if we get into that conversation of, all right, how do we do deployments? How do we automate things? Well, blue-green deployment would look different in app service than it would if you're running everything in virtual machines behind a load balancer, okay? But anyways, kind of moving forward here. So operational excellence, see how much we can automate. And then we get into performance efficiency, right? Again, knowing your options, like scale up versus scale out, and when and how those work depending on the service that you're working with. For example, if I'm doing virtual machines, well, if I want to scale up a virtual machine, what does that mean? It means I'm making a VM bigger than it used to be. For some of us coming over from traditional virtualization environments, we're used to just right-clicking on a VM and going to the properties and giving it more memory and more CPU. I think most of us know at this point Azure doesn't work that way. So if we're scaling up on a VM, that's an outage for that VM, right? It's got to basically reboot. We go from 1 CPU to 2 CPUs. That's a t-shirt size virtual machine, right? So it's like going from one size to another. Boom, we got to relaunch the VM. If we're an app service as an alternative to that, if we wanted to scale up an app service plan from an S1 to an S2 or a P1 or whatever, scaling up is just changing the service plan type, right? Maybe we've already got multiple instances backing that. And so that might be a little bit of a different situation, right? Scaling out is just your auto scaling scenario. The thing I like about scale out is it kind of works the same way if you're thinking about virtual machines or app service, okay? But you want to have that game plan of how will we scale. And if we're doing virtual machines, maybe we're doing virtual machine scale sets. So as load increases, all right, we add more servers to the mix. Or if we're an app service, we could do the same thing, right? Or even Azure Kubernetes service, right? That can be built on top of when you get your worker nodes, right? Those are in by default virtual machine scale sets. So as a best practice, you want to think about that. How can we auto scale if needed? And maybe do we need to even pick a service that does auto scaling? So for example, if you're thinking about Azure Functions to process events or be an API for your web application, whatever. If we're going with the consumption plan and functions, it's inherently scalable. We don't have to worry about load balancers. We don't have to worry about auto scaling groups. I should say virtual machine scale sets. We don't have to think about that stuff with functions, right? If we're on the consumption plan, the whole platform's just there and it's going to scale automatically for me, right? So those are the kind of things we want to start thinking about. Best practice, though, is to make sure that you can scale if you need to dynamically. Microsoft's working on some really cool stuff too. If you look in the properties of like virtual machine scale sets, or if you're looking at the rule set when you're configuring auto scaling for app service, you can see that they're introducing predictive scaling, which uses machine learning. And it's been looking at the activity on your systems and helping you with that. So it'll be interesting to see where that goes. Another thing in terms of performance and trying to optimize, you really want to think about network performance. So like on VMs, do you need accelerated networking support? For your web applications, do you need CDN? Also, what is a CDN? One of the things I've worked a lot with on people that kind of seems like, unless you're a web developer, CDN might be a foreign concept, but that's content delivery network, right? So there's the Azure CDN. There's CDN-like capabilities you get with certain services like Azure Front Door. Okay, so that from a networking perspective, right, we want low latency access to content or data, I should say. So if we're doing a web application and maybe we have a global audience, right, we want to think about making sure our static assets are close to the end user. If I'm, sharing a bunch of streaming videos from a web app that are ultimately the MP4s are in Azure storage, right? Having a CDN in front of that and having the storage account be kind of the origin for that content makes a lot of sense, right? Because then I can, with the CDN, cache data closer to users where they're at. But on the alternative to that, like virtual machines have accelerated networking capabilities. Do you need that? Obviously, that's going to cost more money. And depending on the workload, you may absolutely rely on that, right? Another concept to help you with performance on the network side might be loose coupling. Okay, so instead of having tightly coupled systems, maybe you're distributing or you're adding some things into the mix, like caching. You're, maybe adding a couple different things. I'll show you a diagram on this. That also gets us into the conversation, I should say, about storage performance. So there's caching, storage tiering, right? Things like that. That also kind of starts getting into costs, right? One note though on the networking stuff, not really best practice, but just something to think about. So I've seen people get hit with this and not realize it. there is outbound data transfer costs. And I've seen a lot of people not factor that in, right? So I think a lot of people probably know this at this point. If you've been studying cloud stuff, generally it's like that across the board in any provider. Pump in as much data as you want, but once you start pumping data out, right, there's a bandwidth costs after you get to a certain threshold. And that's something that you want to be evaluating in your architectures and thinking about. I tell a story often when I'm doing these workshops about a customer that was doing, a bunch of MP4 videos in a storage account. And people were viewing, watching those in an embedded browser. And yeah, that's a lot of data transfer when there's tons of videos, right? And then ultimately, you're looking for bottlenecks at the end of the day, right? So where's the bottleneck? And so that kind of takes us into one visual that I could give you guys. Actually, let me take you into this checklist first, and then I'll show you this other architecture. So performance efficiency checklist, this is very application centric, right? This is going to be using terminology for the most part that a developer would understand. If you haven't done a lot of software work, you've done more infrastructure work, especially like traditional Windows, this might seem kind of like a different language, but depending on which ones you have here. But I would encourage you to go through this. It talks about a lot of the stuff that I just mentioned, and then goes into a little bit more detail on data management, okay? But let me show you an example here. So here's an architecture from the Azure Architecture Center. It's all about, loose coupling, right? And there's a bunch of stuff going on here. Look at the far left. Azure Front Door and Azure CDN are in the mix. Common question would be like, why am I using both, right? Why do I have Front Door in front of App Service and then Azure CDN in front of blobs? Well, if you think about it this way, going back to the conversation I was talking about earlier, we want low latency access to static content. So imagine that this whole thing we're looking at is just one region, right? It's just one set of infrastructure in a resource group in one region. That might be West US 2, for example. That's where most of my stuff runs. But let's say that, I've got users all over the world. I've got users in Australia and China. And, when they hit this web app, the web app is going to embed some MP4 videos that are in that storage account just underneath. Right. So here's the reason why they're mixing these different technologies, right? So number one, Front Door is kind of like it's kind of like a multi-purpose geo-redundant load balancing solution. It's almost kind of like having a layer 7 load balancer that can span multiple regions. Okay, so it's got some CDN-like capabilities built into it. It's also got some layer 7 type firewall capabilities built into it, like SSL termination, stuff like that. But it works across regions, right? So it's fronting the app service web app. Now, also though, there's a storage account where the static content is going. You think about it this way, app service is managed, right? Those VMs powering your app service, they're just managed. You can't get into those. You can't VPN or SSH in. Microsoft's taking care of the patching, the backups, the HA for those guys. So you don't want to load that thing up with a ton of static content, like 100 of your MP4 video files, right? So they're putting the video files in this fictitious scenario that I'm explaining in the blob storage just underneath. That has its own DNS URL, right? Because of that, if we want to cache that data close to where users are at across the world, we're fronting it with Azure CDN. I know I'm throwing a lot at you, but these are just kind of things that you got to think about when we're architecting, right? Does it make sense? If you have a global audience, absolutely. If you don't have a global audience, might be like, who cares, right? All of our users are down the street, like it doesn't matter. But there's another thing here in the mix that is all about loose coupling, right? It kind of goes back to some of the points that were on the slide a minute ago. Notice that in between the web app and ultimately the data storage on the back end, we've got a ton of stuff going on here. Number one, we've got a queue, we've got a function app, we got Redis cache. What's the story with all this, right? Why can't we just have the web app talk directly to the database? Well, we could. That would totally work. We could just have the app service plan. I could navigate to the app service website. Maybe I got a form on there where I submit a form and something goes into a database. That's cool. I can talk directly from the web app to the database, but that's tight coupling. Okay, so an example of loose coupling, this isn't always gonna be valid for every scenario, but imagine that you're constantly hammering the heck out of the SQL server, or actually, let me say this. Imagine that you want to have not only performance efficiency, but you also want to have the ability to persist this stuff if the database implementation is down. So whether it's like really busy SQL Server or if it's just completely down, placing a queue in the mix is all about loose coupling, right? And it's also going to give us more performance scalability. So users are hitting a web app, when they submit the form, we just drop a message in the queue. And we know with things like function apps, we can have event-driven functions that respond to events. So think about it this way. User submits a form on the website, goes into the queue, function app gets the message and knows, oh, okay, I got to take this data and put it in the database. Tries to do that. If the database is too busy to accept that or it's down, the way that we have this thing structured is that the message just goes back to the queue. And then later, maybe I've got the equivalent function running on a timer coming by to pick up anything that didn't get processed, right? That way, the database could be completely slammed or could be even offline, but I still got the stuff in the queue and I can process it later using something like a serverless function. On the flip side of that, there's a Redis cache in the mix. And so imagine that you're constantly reading the same data out of the SQL database 5,000 times every 10 minutes because it's just common for your application, right? Well, we can cache those reads in something like Redis cache. That's another way to squeeze way more performance out of this. So I could go on, but I'm going to move forward here just in the interest of time. So in terms of security, the security pillar, a couple of things here really important, but the link at the bottom of this, like if you're a security geek, you're going to love this if you haven't seen it, because there's, I don't know, a couple hundred security best practices. I'll bring up that link in just a second. But a couple of things to think about here. Defense in depth. And that kind of takes you right into the shared security responsibility model. Okay, so defense in depth is really the image on the left there. Every layer, we want to be thinking about security at every layer, right? We know at the physical layer, Microsoft's pretty much doing that, right? They got the armed guards and all that kind of stuff at the data centers and the biometric scanners, all that kind of stuff. So physical security, Microsoft's take care of that. But once we start getting into these other layers beyond the physical world, right? Policies and access, perimeter security, network security, virtual machines, application, data, it goes on and on and on, right? And so basically the big thing to think about here is there's a million ways to expose your secrets accidentally, right? You could do something by lack of policy implementation that allows the people on your team to, inadvertently expose something, right? You can have a perimeter security issue where you get a denial of service. Microsoft does a good job of protecting against that by default, but you never know, right? Networking stuff where you're leaving ports open when they're not supposed to be, things like that, right? You get the idea. Weak passwords on your VMs, on and on and on. If you're anything like me, probably the number one security issue you see on the internet all the time is the stories about how people checked a password into a GitHub repo that was public. We all know what happens then, right? The Equifax thing happens, all that kind of stuff. And then also just to the right of that, just hammering home that idea is the shared responsibility model, right? So you've got responsibilities. Microsoft's got responsibilities. It's your job to understand, depending on the situation, what are you responsible for? For example, if you're doing app service, you're not so worried about the patching and maybe, the host level security of the VM powering your web apps, right? Because Microsoft's managing that infrastructure. It's a managed service. So you're getting a lot for that exchange, right? You're giving up some control, makes it easier for you to operate the application and support the system, all that kind of stuff. But when you're doing VMs, like the security of that VM's pretty much on you, right? You got to make sure it's up to date. You're not putting a weak password on there, and you get the idea, right? So things to think about on that model, but also this link here, like I said, just a massive amount of insanely good information. Multiple best practices for, and these are all security focused, but boundary, database, network, and just on and on. So again, this would be something I'd be studying, especially if security and security architecture was super important to me. But, I think security is, it's one of the most important things these days because it's so easy to open something up these days. Finally, it takes us into cost optimization, and I'm going to take you guys through a couple other things real quick, and we'll do some Q&A. All right, so provision with optimization in mind. really, go. Can you go PaaS? Can you go managed service? That's really kind of what I'm getting at. Can you lead with managed services? Because if you can, chances are you're going to have less things blowing up on you. Not to say that IaaS is no good. It's just it's much more complex. There's a lot more involved. There's more moving parts. There's more things for you to glue together. That means there's more things that you have to own and keep an eye on. So it's much easier if you can lead with PaaS, platform as a service, versus IaaS, infrastructure as a service. So instead of reinventing the wheel on VMs, can you use app service? Can you use, Azure container instances or, things like that? What are the alternatives? Start there and see if you can save yourself, not only from an operational perspective, but from cost, right? Use monitoring and analytics to gain cost insights. And then also another big one here that comes into this is can your non-production environments, unused outside business hours, be shut down to reduce costs? I see that a lot. I see, and I've seen a lot of people lately too doing automation around shutting stuff off that's not being used during the day. And sometimes it's not even non-production. I had one customer talk about these guys a lot. It's just a high school, right? And they had a computer lab. You ever use one of those Weiss terminals to like RDP into a Citrix server or something? Or I guess that's not what it is. What was it? Citrix Metaframe or like terminal server, stuff like that back in the day. Well, at the high school, they just had these terminals and they were all just configured to RDP into Azure VMs, right? And so this guy that I was working with, he ended up just using Azure Automation to shut the VMs off at the end of the school day and power them back up the next morning, and only do that Monday through Friday, right? So it's just kind of like leaning on some of these optimization capabilities and automation capabilities to save some costs. But also looking at the data. That's another thing where I see people, they're spending thousands in some cases and they're not even using it, and they don't realize it because they're just not paying attention. Somebody launched a sizable virtual machine because they wanted to test something, and all the information's right there in the analytics, right? Tells you why you're spending, but people aren't paying attention, right? So it's a big thing to think about here. There is a cost design checklist in the well-architected framework that I would go through. Don't have time to dive into this in depth today, but tons of great content in this. Also, total cost of ownership calculator for migration projects, insanely beneficial, because that's another place where people get, they don't tend to always think about the long term, right? Total cost of ownership calculator will help you with that, because then you can start to paint the picture of like, if we do it this way, it's going to really save us on cost in 3 to 5 years. Sometimes where people are just thinking about this year, you know what I mean? So that's something I would dive into. Okay, so number one, this is still new, but and I have not gone through this yet. So, your luck, your mileage will vary with this. I know Microsoft's been working hard at this stuff, but there is a well-architected review. So you could hit this link here, go through this process, click on Microsoft well-architected review, and basically examine your workload, your proposed design against, through the lens of reliability, cost, management, operational excellence, security, performance efficiency, all that kind of stuff, all the stuff that we just talked about, right? It'll quiz you more on some of these things and give you more clarity about your architecture, right? And is this going to actually play out the way you want it to? So amazing resource to check out. Then the cloud adoption framework. You could spend a lot of time in here, but for the sake of this conversation, I've linked directly to the readiness section, the Azure setup guide, right? Because there's some really interesting stuff in here. So basically, number one, organize your resources. So like, how are you going to set up your management hierarchy? This is like, honestly, this is one of the first things anytime I'm working with a new customer, and most of the customers I'm working with are completely brand new. That's whether even they even want to talk to me in the first place, right? But they don't usually have any of these right, especially number one. Usually they've organized things kind of in a shotgun approach. So as an architectural best practice, right, you want to make sure that you got a real solid understanding of the hierarchy, management groups, the subscription design guidance from Microsoft here in the in the cloud adoption framework. We don't want to do production workloads in the same subscription as our development workloads, right? There's tons of guidance around that, but understanding this hierarchy here of not only that, but when it comes to doing permissions, right? Delegating permissions at these different levels, like that's really important as well. from an architecture perspective, naming your resources, insanely important, right? So a ton of guidance in here, and it's, kind of depends on the service you're working with and all that kind of stuff. What I've found is, just having a standard that makes sense for your organization is better than nothing at all. The challenge with that is sometimes you'll get into a service and you might realize, oh wait, our naming standard isn't going to help with that, or isn't going to work. For example, I'll give you one common one I run into all the time: storage accounts in Azure, right? Got to be globally unique host name, and you're limited to DNS rules, right? So you can't use wacky characters or like these huge long names. There's rules in that world, right? It might be different for something else you're working with, and so doing some of that front end work, or at least just consulting this stuff, is a best practice, right? Have a naming standard. One of the reasons I've seen customers get kind of messed up on this stuff is, I don't know if you notice this, but if you've ever deleted a VM, right? If you go into a resource group and like delete the VM, like it's just, there's a VM object, right? But then there's all the dependencies like the NIC and the disks and all the other components that make up the VM, right? But I had one customer that thought just deleting the VM object itself would get rid of all the resources, right? And since nothing was named properly, and since nothing was tagged properly, we didn't, they had no idea what they were looking at in the portal. Like, can we delete this? Can we not? I know that sounds really basic, but covering your bases here, make sure you're doing tagging. I think that's, something that Microsoft hammers on from the Azure fundamentals layer all the way up. And we can automate this now with policy and stuff like that. But these are all things that you want to make sure that are solid, right? So that's kind of number one there. And that was in the readiness guide. So that was step one, right? Organizing your resources. Next one is managing access. So again, if I was interviewing you or somebody for an architect position, like I would want you to be solid with role-based access control, right? Because this is so important. Like we just talked about, security is paramount. And if you don't know this well, it's going to be really hard to succeed. So, not only, best practice is principle of least privilege, right? Let's not open up a bunch of stuff that we don't need to. Let's not give people access that don't need access. Let's not open a bunch of ports that don't need to be open. Let's not give somebody permission to something that they don't need permissions to, right? We've been doing this our whole IT career. But knowing how Azure does it and how RBAC works in Azure, and not only are, how do the canned rules work, but how the custom rules work, super important. And that also can start taking you down the rabbit hole of, blueprints and ARM templates and all that stuff, right? Which is amazing, and you should do that. But first, you got to understand the fundamentals, right? Got to walk before we run. All right, so, and this thing goes on and on. Manage costs and billing, governance, security and compliance, right? You get into policy and all this kind of stuff, monitoring, and then how to stay on top of Azure, like with updates. So I'm not going to get into all those because we're already almost at the hour. But last thing here, Azure landing zones. So, once you start to, and this is why I kept this last, because this could be pretty much, if you're brand new, this thing, if you walked right up to this from scratch, it's going to blow your brains out. So if you're solid with all the other stuff I kind of talked about, and when I say solid, just like you understand kind of the big picture, right? You don't have to be an expert in every area, but then you can start, getting into landing zones, right? And so this is really interesting work that Microsoft's doing. I know that this is something that's been emerging and it's maturing and getting better and better. But the concept is, basically a landing zone is an output of a multi-subscription Azure environment that's already thinking about scalability, security, governance, networking, and identity for the long term, right? It's a way for you to almost prescriptively architect your solutions, right? So I wish I had more time to dive into this today, but I would highly encourage you to head over to this section of the Cloud Adoption Framework, read up on, what are landing zones, kind of understand this concept. But when you start getting into it down here, here's a basic architecture, and I do some guidance here, but down here, this is really where, they dive into the depths of this. And so I'll leave this to you to kind of research on your own for 2 minutes to the hour. But, as you can see here, highly prescriptive implementation of every aspect, right? You've got your management group implementation, right? So you're starting to think about your subscription governance, how things are going to play out. You're starting to think about your automation capabilities and putting your infrastructure templates and your Azure policy, your custom Azure policy stuff, your custom RBAC implementation, like any of that code stuff, right? Doing the DevOps thing and on and on and on, right? So Azure is insanely big, but it's good news for us because they're going to need our help, right? Everybody is trying to get better with this stuff. So that is my presentation for today, everybody. I hope that you got some use out of this in the limited time that we'll have to kind of go through it. And I'll give the slides over. I'll just email them over later tonight so you can post them. But yeah, happy to do a couple minutes of Q&A. And then
hey, thanks, Mike. It was very informative. There was a question someone asked, going back to the first architecture that you have shown around the reliability. The question was, web tier subnet is not possible to connect to the load balancer.
Can you repeat the question? It's not I didn't hear
the web tier subnet, is it not possible to connect that to load balancer instead of an application gateway?
Oh, you could. Yeah. So the reason that they're showing the app gateway here is since it's an internet facing workload. So, we could put Azure Load Balancer right here. We do need to make sure, though, if we're spanning multiple availability zones, that it's not the free Azure Load Balancer. It's the paid SKU. I think it's the standard SKU. I think basic is free and standard is the pay one. But really the reason, right, that the application gateway in this architecture is on the outside world is because we could put SSL certificate on the app gateway. So do, SSL termination here. We might have multiple groups behind this app gateway. So we could do, path-based routing. So maybe contoso.com/videos goes to this set of servers and contoso.com/images goes to another set of servers. And then, more things like session affinity and more of the things that we're expecting to see on a web optimized load balancer. And so, yeah, Azure Load Balancer would work there, but they're showing the application gateway for those reasons. That makes sense?
Does to me, I guess, it does to the person who has asked the question. There is no other question in the chat, but if anyone has any questions, feel free to unmute yourself and you can ask Mike if no one else has. I had few points. Mike, I was super happy to hear that there is something like predictive scaling coming up in virtual machines. I have not seen that anywhere. Probably I might do some research on that front and see, but it would be a great addition for sure.
Yeah, it's really interesting. If you go into the rule set for like a virtual machine scale set, like you're going to go set up auto scaling rules, you'll see that, I think.
Okay.
Yeah,
I'll check it out. And I guess cost optimization was the great architecture. So I had a question about that, Mike. I have given this Azure role-based certification for solution architect last year. At that time, this well-architected framework was not there. And when I was preparing for my certification, I went through the Azure architecture. Every page I read every page of it because I knew it's like the Bible for that exam if I had to clear that exam. So do you think well-architected framework also is equally important for any aspirant who is preparing for those certifications?
Yeah, absolutely. What I would do is kind of the common thing that we do for certs is get the skills measured, find the points where you're not clear, and then not only just the raw documentation for those points, but also where can you find that in the cloud adoption framework? Where could you find that maybe in a well-architected framework? Because not only will it help you answer the test question, you'll start to understand more like how are the folks in the field engaging with their customers. And that's why I like the architecture center and well-architected framework, cloud adoption framework, because that's all like, developed by engineering teams and field people talking to customers and stuff. Whereas, I don't know all the relationships inside Microsoft, but the learning folks are focused on learning, and that's important. But I think you might see some more real world stuff if you start digging around in these things that I've been showing today. So yes.
I haven't seen the new exams. I know there has been some new exam numbers for the role-based certifications, and probably they might have included well-architected framework in these objectives as well.
Well, I've looked at the objectives and I haven't seen them call it out specifically, but the concepts, the overarching concepts are in there. To your point, the two new exams are, I think, going live at the end of this month, if I remember correctly. haven't looked in a while, but the skills measured and what's on the test is actually very, very similar. They've, arranged some things, they've moved some stuff out, brought some stuff in, but for the most part, it's very similar. And by the way, I just finished co-authoring the Easy 303 book with Tim Warner and a few other people for Microsoft Press, and
Awesome.
that'll be out later this year. But yeah, we had to kind of like really think about that hard. It was a bummer because we wrote the AZ 300 book and now we had to like rewrite it. But what I want to share there, in addition to plugging my book, is we didn't have to like reinvent the wheel too much because most of the information was very similar. So
Awesome.
303 and 304, the new exams for Azure architecture, will be very, very similar to the old ones. So if you've been studying for the old ones, don't let it set you back or hold you back, would be my advice there.
All right. Last point that I noted was when you were talking about the management groups and the structure, it's very powerful. And you did mention about the role-based access control permissions, how they are inherited. And I would just wanted to add that it's just not only the role-based access control, but the Azure policies that we can create, they are also inherited in that hierarchy. So which is also very powerful.
Yeah, definitely. It's a good follow-up for that for sure. That's also and for anybody that's DevOps focused and really interested in the automation side of that, blueprints are interesting. They've been in preview for a long time, or at least it says preview in the portal still. But it's really kind of the combination of the ARM template, Azure policy, your RBAC implementation in a way that you can do these repeatable deployments. But that is super powerful because, if you think about it, if you can do your permissions at various scopes, right, whether it's resource group, subscription, management group, it really opens up a lot of capabilities. So you can get very granular with a combination of Azure policy and role-based access control. So that's a great point. Well, I appreciate everybody's time today.
Thank you so much for taking out time, Mike.